Now we are going to discuss how absolute configuration is assigned for optical isomers. We know that absolute configuration is the three-dimensional arrangement of atoms or groups in an asymmetric molecule. So to describe the absolute configuration of a chiral center, R and S nomenclature was used. This nomenclature of configuration to an optically active compound is based upon the nature of groups or atoms attached to the asymmetric center and the priority assigned to them. The absolute configuration is assigned by a prefix R or a prefix S, depending upon the sequence of the groups or atoms. The letter R is originated from the Greek word rectus, meaning right-handed, and the letter S is originated from the Greek word sinister, meaning left-handed. Let's see what are the steps involved in assigning absolute configuration and the sequence rules to determine the order of priority. The first step involves the sequence rules for assigning the priority to the groups attached to the chiral centers or chiral carbon atoms. The first rule is that the greater is the atomic number of atoms attached directly to the chiral carbon, higher is the priority. For example, if hydrogen, OH, CH3 and Br are the groups attached to the asymmetric carbon atom, then the order priority will be bromine, oxygen, carbon and hydrogen. Because among this group, bromine has the highest atomic number, it is 35. And oxygen 8 and atomic number of carbon 6, hydrogen 1. So the priority order will be like this. And then comes rules 2. If two isotopes of the same element are present, the heavier isotope has the highest priority. That is, among D and H, these two are the two isotopes of hydrogen. D is the heavier isotope, so it got the highest priority. Similarly, in this case, carbon 13 and carbon 12 are the two isotopes of carbon, and carbon 13 got the highest priority because it is a heavier isotope. Then we have rule 3. If two atoms directly attached to the asymmetric carbon are identical, that means if the two atoms have the same atomic number, then the atomic numbers of the next atoms are used for assigning priority. For example, between the two groups CH3 and CH2OH, here we can see the first atoms in these two groups are the same, two carbon atoms. Then then we go to the next atom. So the latter, that is CH2OH, got the highest priority. Then rule 4. A doubly or triply bonded atom present in a group attached to the chiral carbon is considered equivalent to 2 or 3 singly bonded atoms in determining the priority. So these are the 4 sequence rules for assigning priority. Next we have step 2. Step 2 involves the orientation of the groups or atoms around the chiral carbon atom. And the orientation of groups around the molecule should be in such a way that the group of lowest priority is directed away from the viewer. And step 3. In this step, we assign the configuration S or R to the molecule. For this, if in moving from the first, second and third priority groups, the eye travels in the clockwise or right-handed direction, the configuration is assigned as R. And if in going from first to second and then to third, and in going from first to second and then to third priority groups, the eye moves in counterclockwise or left-handed direction, the configuration assigned is R. Now we have some examples. The first example is 1,1-chlorobromoethane. Formula is CHClBrCH3, and this is the wedge-Hush projection formula of 1,1-chlorobromoethane. This is the asymmetric carbon atom, and the four atoms directly bonded to the asymmetric carbon atoms are bromine, chlorine, CH3, and hydrogen. The priority order of these groups are like this. Bromine has the highest atomic number, 35, so it got the highest priority order, priority number 1, followed by chlorine, priority number 2, and then carbon 3. Least priority goes to hydrogen 4. And while viewing the molecule according to the priority order, the eye travels in the clockwise direction, bromine to chlorine to CH3. So we assign the configuration R to this molecule. But in this case, while viewing the molecule according to the priority order, the eye travels in anti-clockwise direction. That is, first atom bromine to chlorine to CH3. First, second, and third. Eye travels in the anti-clockwise direction. So we assign the configuration S. Then this is another example, bromochlorofluoromethane. The four atoms directly attached to the asymmetric carbon atoms are bromine, atomic number 35, chlorine, atomic number 17, fluorine, atomic number 9, and hydrogen, atomic number 1. Hence the priority order is bromine, followed by chlorine, followed by fluorine, and hydrogen. And in viewing according to the priority order, the eye travels in the anti-clockwise direction. That is from bromine to chlorine to fluorine. Direction is in anti-clockwise. So the configuration is S. And in this case, the movement of the eye according to the priority order while viewing the molecule is in clockwise direction. So the configuration we assigned is R. Okay. The next is assigning configuration using Fischer projection. In this case, we have to remember that horizontal lines and vertical lines are used to represent the bonds in Fischer projection formula. And the point of intersection represents the asymmetric carbon atom. So here we have to remember one thing, that if an atom or group of lowest priority occupies vertical position in the Fischer projection, then the configuration update gives the actual configuration of the molecule. However, the atom or group of lowest priority occupies the horizontal position in Fischer projection, we need to reverse what we obtained. For example, in this compound, the four groups attached to the asymmetric carbon atoms are CH3, H, CHO, and COOH. The first priority goes to COOH, second CH3, third CH3, 3 and 4 hydrogen. So this is S configuration. This is another example, 2 amino propionic acid. And this the 4 groups directly attached to this carbon asymmetric carbon are amino group NH2. It has got the highest priority, and COOH acidic group second priority group, and CH3 methyl group third priority, and the least priority goes to hydrogen. So in this case, while viewing the molecule according to the priority order, the eye travels in the clockwise direction. So the configuration should be R. But since hydrogen, the least priority group hydrogen is on the vertical line, we need to reverse the configuration what we actually obtained. So we finally assign the configuration S instead of R. Similarly, in this case, the 2-bromopropionic acid. The 4 groups attached to this are bromine, highest priority group, and then COOH, second priority, CH3, third priority, and hydrogen, lowest priority. Here also this hydrogen atom is on the horizontal line. That means the least priority group is projecting towards us. So here also we need to reverse the configuration what we actually get. And in this case, the eye travels in anti-clockwise direction. So the configuration should be S. But here we have to reverse the configuration for getting the actual configuration. So we assign the configuration R instead of S. And next comes the configuration of glyceraldehyde. The 4 groups attached to symmetric carbon atoms are OH, highest priority group, then CHO. This contains a doubly bonded atom, C double bond O, that got the second highest priority, and then CH2OH, the third priority group, and hydrogen, the least priority group. So these are the 4 groups attached to the asymmetric carbon atom in glyceraldehyde. In this case, while viewing the molecule according to the priority order, the eye travels in the clockwise direction. First carbon, first priority group to second priority, and then to third priority. So we assign the eye travels in the clockwise direction. So we assign R configuration, but the least priority group is on the horizontal line. So we have to reverse the configuration. So finally, the molecule got the S configuration. Similarly, in this case, the least priority group is on the horizontal line. Vertical line. Hydrogen is on the vertical line. So in this case, we assign the configuration what we actually obtained. There is no need of reversing the configuration. So this got the R configuration, because in this case the highest priority group is OH, second highest priority group is CHO, and third one is CH2OH. So while viewing the molecule, the eye travels in the clockwise direction, and also hydrogen is on the horizontal line. So we assign the configuration R what we actually obtained.